In this problem, we're taking a look at functions that appear to be of the form something over x, and we'll recall that in order to get 1 over x as the derivative of some function, the function that you have to take the derivative of would be the natural log of x. Now, we have to be careful here because for reasons we won't explain right now, we have to have the absolute value of x. Keep in mind that this guy can have negatives in for x, but this guy cannot. So if you take the natural log of a negative number, you have a problem. So that's kind of one way to justify it in our minds. Okay, so in letter A, well, that one's just going to be the natural log of x plus c, because that's exactly matching what we have over here. Now we have the integral of 3.2 over x dx. Well, what I can do is, just like when I take derivatives, recall that when we take derivatives of something like this, for example, what we're going to do is we're going to drop down the exponent, right? So really what we could do is ignore the 4 for a second, and if you can just kind of cross this out in your mind and just see x cubed, well, we'll multiply it in later, but the derivative of x cubed is 3x squared, which, you know, when we do this, we just actually just combine it right away in one step and call it 12x squared. So we're going to do the same thing here. We're going to factor out the 3.2 because we're going to multiply it back in. It's a constant, and we can see that now we have 3.2 times the natural log of the absolute value of x plus c. In letter C, much the same thing, except that we have 1/12 here is a way you can think about it. So I'm going to factor out a 1/12, integral of 1 over x dx. Keep in mind that I multiply it back in, the 12 goes into the denominator, and that's going to be 1/12 natural log of the absolute value of x plus c. And now letter D, much the same, except we have to factor out a 4/6 times the integral of 1 over x dx. That's going to be equal to 4 over 6 natural log of x plus c. And finally, in letter E, we're going to we have two terms, so we can integrate term by term. The first one, you're probably noticing the pattern, will be 2 natural log of x. The second one will be minus 3.1 over 2 natural log of x plus our arbitrary constant.